So let's look at what happens when we perform that operation. And you'll notice this is one of the cases where I'm only doing one operation on this step. And that's a personal rule that I highly recommend you adopt for now at the very least. It's not strictly mandatory, but I can't think of a good reason to do more steps, more operations on this one step. If I'm turning a non-zero entry into a leading one, I make a point of only doing that one operation on this step. It's again, it's not something you absolutely have to do, but I can't think of a good reason not to just limit ourselves to this one step. So what's going to happen? The first two rows won't change. Right? We'll have 1, 0, 1, 2, 6, and then 0, 1, negative 2, 0, negative 3. Those two rows won't change at all. Now the third row, we're multiplying by half. So the two zeros at the beginning of this row, they won't change because 0 times anything is just 0. But all these 2's now are going to turn into 1's. So we'll have positive 1, negative 1, negative 1, and then the fourth row will still just stay the same. We'll have 0, 0, 3, negative 6, negative 9. Okay, so now we've got ourselves a leading one. The leading ones appear in this nice downward staircase, but now this is running into the problem where this leading one now is not the only non-zero entry in its column. In fact, there's not a single entry in that column that's equal to 0, but we need to make it the only non-zero entry in its column. So let's do that at this stage. We can do all, now these are safe to do all at once because we can subtract row 3 from row 1. We can add row 3 to row 2 twice to get rid of that negative 2. And then we can subtract row 3 from row 4 3 times to get rid of this 3. And none of those operations cause any conflicts with each other. There's no risk of confusion. So this is the case where now we can do several operations in one step. So let's take row 1 and replace it with row 1 minus row 3. We'll take row 2 and replace it with row 2 plus 2 row 3. And then we'll take row 4 and we'll replace it with row 4 minus 3 row 3. We're using this leading one to get rid of all the other entries. That's also a pattern that you will always see when you're doing Gauss-Jordan elimination. Okay, so let's roll up our sleeves and perform these steps. Only one of the rows is not going to change, and that's going to be row 3. So row 3 will stay at 0, 0, 1, negative 1, negative 1. So that's the part that won't change. What will happen to row 1? Well, let's just do the subtractions. 1 minus 0 is 1. 0 minus 0 is 0. 1 minus 1 is 0. That's what we wanted. That was why we chose this operation, to get a 0 here. 2 minus negative 1, that's going to give us a 3. And then 6 minus negative 1 will give us a 7. Okay, what about the second row? We're going to add row 3 to the second row twice. So these zeros won't have any effect on these entries. So the first two entries are not going to change. They'll just be 0 and then a 1. We're going to go negative 2 plus 2 times 1. That's negative 2 plus 2, which is 0. 0 plus 2 times negative 1. That'll give us 0 minus 2. So we'll have negative 2. And then over here we'll have negative 3 plus 2 times negative 1. That's going to turn into negative 5. Notice that we lost one of our zeros over here. By cleaning up this third column, we actually lost one of the this 0 turned into a negative 2. So it may seem like this did some harm, but that's okay. If these operations ever do harm, as long as you're following this approach of working from left to right, you might do some harm to the right of the column you're working on, but you'll never do any harm to the left. Notice that these columns were completely unharmed. I haven't written these yet, but you'll see that these don't get changed either. So even though this 0 got turned into a non-zero number, we can deal with that later because we still are working our way to the right. But over here, nothing bad will happen. So that's our third row didn't change. Our fourth row, we're going to subtract row 3 from row 4 3 times. So these zeros won't change because there's zeros up here being subtracted from them. So 0 minus 0 is just 0. But now we have 3 minus 3 times 1, which is 3 minus 3. Then we have negative 6 minus 3 times negative 1. So that's negative 6 minus 3 times negative 1. That's negative 6 plus 3, which will be negative 3. And then what will we have over here? We'll have negative 9 minus 3 times negative 1. That's like negative 9 plus 3, which is negative 6. So that's what we'll end up with. So like I was saying, this 0 got changed into a negative 2, so any of the damage was done on a column that we have not yet cleaned up, so it's no problem. But over here, these columns that were already done and dealt with, no harm was done to them. It's kind of like if you're cleaning up a room, if you're sweeping up the floor, you want to sweep in one direction so that all the dust collects in one final place where you can sweep it up into a dustpan. You don't want the dust now doing circles around you, getting into the clean parts. Maybe it's a cheesy analogy, but I hope it helps a little bit. So we've got one column left to work on, and so the first challenge is figuring out where the leading 1 is going to go, and this seems like the only reasonable place to put it, with this negative 3. So, I guess it's a bit late now to add this, but just to follow the same pattern of what I've been doing, whenever I circle these numbers and write down what the goal is, let's add this comment. These need to be 0. If you're looking at this later, it'll make more sense if you include that comma. These must be 0. And our next goal on this step is going to be on this entry. This entry must be 1. Okay, so, well, we can do that. There's a single operation that will accomplish that task. Let's multiply this entire row by the reciprocal of that number. So that just means to multiply that row by negative 1/3. So we're going to take row 4 and replace it with negative 1/3 row 4. That'll be the only step we need to do or the only operation we need to do for this step. So the first 3 rows will not change. But our 4th row will actually become exactly what we want it to be, 0, 0, 0, 1. And then what if I multiply this negative 6 by negative 1/3? That'll become negative 6 divided by negative 3. That'll be positive 2. So now we're almost done. We just need to make sure this leading 1 is the only non-zero entry in its column. So all of these entries now need to be cleaned up. So those need to be 0. Be 0. Okay, so how can we do that? We'll do that in the usual way. We'll use this leading 1 to accomplish the job. So we'll have to subtract it from row 1 3 times. Then we'll add row 4 to row 2 2 times to get rid of that negative 2. And then we'll take row 3 and we'll add row 4 to it once to get rid of that negative 1. So those are the operations we'll do. And this, you can see that if those are zeros, this will be in reduced row echelon form and we'll be good to go. So we're almost done. So let's carefully work out what will happen. So the first row, well, these zeros aren't going to do any changes to these first 3 entries. So the first row, we can safely just go 1, 0, 0. Now, if we subtract row 4 from row 1 3 times, then 3 minus 3 times 1, that'll be 3 minus 3, give us a 0, just like we want, right? That was the whole point of this. 7 minus 3 times 2 will be 7 minus 6, which is 1, and that's the first row. So for the second row, again, these 3 zeros are not going to change those 3 entries, so you can just write them down without doing any calculations, because these are the only thing that's going to make any changes. So if we add, what are we doing? We're adding row 4 to row 2 twice. So add that 1 to that negative 2 twice. You're going to get negative 2 plus 2, which is 0. And then negative 5 plus 2 times 2, which is negative 5 plus 4. So you're going to get negative 1. And then our last row, we can fill it in. Again, these 3 zeros won't change those 3 entries, so we can go 0, 0, 0. But then now we're adding row 4 to row 3. So this entry will change because there's a 1 here. So if you add negative 1 and 1, you get here's a mistake. When I said these 3 zeros when we add them to these three entries, 0, 0, 1, I wrote 0, 0, 0, but this should be a 1. So that should be a 1 there. But this negative 1, when we add 1, we'll get 0. Okay, and then when we add 2 to the negative 1, we'll have positive 1. And then our last row won't change. So we have 0, 0, 0, 1, 2. So now we have ourselves an augmented matrix that's in reduced row echelon form. So let's circle all of our leading ones just to run through the check, just to make sure that all of our rows and columns satisfy the appropriate conditions. So first of all, check that all the rows of zeros are at the bottom. And that's certainly true because there are no rows of zeros. Then we want to check that the first non-zero entry in each row is a 1. And we've already circled the first non-zero entry in every row, and they're all 1s. Then we want to check that they appear in a downward staircase form to the right. They certainly do. Finally, to check that it's in reduced row echelon form, check that every leading 1 is the only non-zero entry in its column. And that's exactly what you have here, right? This leading 1 is everything else is 0. This leading 1, everything else is 0, and same with the other two leading 1s, right? Those leading 1s are the only non-zero entries in their column. So this is in RREF, reduced row echelon form. And we are ready to extract the solution. And since this time every single column contains a leading 1, that's synonymous with saying that the 1s appear downward in a perfect diagonal from top left to bottom right. If that's the case, then you're not going to have any parameters, because that's exactly how you decide which variables to assign parameters to. The ones whose corresponding columns do not contain leading 1s. But every column has a leading 1, so there won't be any parameters here.